Hi, I'm Geoff, and we would like to introduce to you Interep. Interep is a project from the Ethereum Foundation's Privacy and Scaling Explorations team, and we're tackling the problem of identity. Specifically, we want to bridge real-world identity via digital identity into the Ethereum world and the web3 world. So our aims, we want to integrate with various sources of digital identity and bridge those sources to Ethereum, and then use them in Web3 applications and make sure there's privacy in the middle, so that the original source is not made public. Just to explain how where we fit in an application layer, your application would provide the user interface. We're built on the Semaphore framework. Semaphore is being used in lots of privacy applications these days. Several of the projects we'll be hearing about today utilize the Semaphore framework. We fit with Semaphore as the identity layer below that, and we route our data on the blockchain, but we provide the link between digital identity sources and Semaphore groups. So we'll talk more about how Semaphore groups work in a minute. But yeah. Semaphore is providing the ZK proofs for privacy, and we're providing the identity management. When we think about identity, real-world identity, I think we can all relate to, but it's mirrored in our digital identity sources. Consider social network profiles. People work hard to they put content into their Facebook profile and their Twitter profile, and that's a reflection of their real-world life. Of course, Twitter has heaps of bots, and we need to filter those out when we're dealing with the problem of identity. But the idea is people work, and that work is kind of proof that account is, there's a real human behind it. So what we're seeking to do is filter out those bots and have some sort of approximate guarantee that there's a real human behind the sources that we use. So the easiest to relate are social networks. We've integrated with Twitter, with Reddit, with GitHub. Each one of those, they provide OAuth authorization gateways, so we can easily capture someone's or authorize someone against their social network profile. The next step, though, is to have a look at their profile and do an assessment on whether we think that's a real human or a bot. There are tools out there to help us do that. But yeah, so social networks are an easy way for someone to provide a digital identity that can be used in Interep. And applications can consider our possible sources of identity and say, yeah, that one suits me. It gives me a good pool of users that I can use, and yeah, go with that. So, whoops. But it's not just social networks that we use. We can we've experimented with integrating with various other sources. Now, email is not always a good source of identity because it's easy sometimes to create many emails for a single person, but something like a .edu domain is handed out to an individual who works for an educational institution. So there's a way that we can use email to have a reasonable guarantee that there's a unique human behind that email. And even with a Gmail, there's some sort of barrier to creating many accounts, so it's somewhat useful. So email's another source that we can use. Potentially phones, potentially, you're probably thinking your granny hasn't got a Twitter account or an email address, but she does have a government ID, so that's another way we could expand our pool of people to include those kinds of people. So government authorities provide gateways to provide digital ID verification, driver's license verification, or voter registration, or whatever. So those kinds of things we can use. All of these are really just ideas that we've been thinking about. So if you've got an application in mind and an ID source that you could think might be useful, we'd welcome plugins. It's really just it's quite easy to plug in with us. Curated groups, it could be a Telegram group which invites users, and then we can use that group list as a whitelist to form the basis of our group. There are many admirable identity projects coming online. I think we're going to hear from a few of them today. So we could use them as our identity source and create a Semaphore group, and then we add the privacy in the Semaphore, ZK proofs and so on. So that's another source that we could link. And there are sources that are already on chain in the Ethereum world. We could think about something like a POAP, and if it's a POAP that's issued physically at a physical conference, that's a fairly strong guarantee that there's a unique human, because that POAP invitation is handed out in person, one-to-one. And if we also mitigate it with things like, protection against people who sell their POAPs and collect hundreds of them or whatever, then we could, that'd be a very strong source of guarantee of humanity. So yeah, they're just ideas, things that we've played with. So that just gives you an idea of the kind of things that we can integrate with. So, like I mentioned, we integrate with Semaphore. The way Semaphore works is we have membership sets. Set members have a secret, private identifier, and they can use that identifier to signal on particular topics, and there can be many topics, and that the owner of that identifier can reuse their signal on topics, but the proofs guarantee that the identifier is not revealed and that the identifier is not used more than once on a topic. So it's probably easier to relate to a real-world application like secret voting. You'd have guarantees that the person voting is, or the identity voting is, a member of the people who are authorized to vote. But we can also guarantee that they don't vote more than once, and all of that's done in zero knowledge. So that's an example of the kind of things that Semaphore does, but you can think of social networks, and we'll see some more of those later. Whistleblowing schemes and so on. So that's Semaphore. So when we talk about Semaphore groups, they are really Interep groups, and Interep is populating those groups using identity sources. So The method we use is in the user interface. The user will do a proof of membership of their digital identity source. That could be an OAuth authorization session. Proof their membership, and then there's an assessment phase. So some Twitter accounts are good. So if they've got like 7,000 followers in their Twitter group, then that's a fair indication that they're not a bot. If they've got 10, that's not so good. So we would kind of allocate their Twitter profile into a group and say this is a really good quality one or a very quite poor quality one. And those groups would represent different levels of guarantee of humanity. So we're probably going to end up with a large group of people who don't have good qualifications, and a small group with quite strong guarantees. And as an application user, you could look at those groups and say, yeah, I want a big privacy pool, so I'll choose the large group. Or I want strong guarantee of humanity, so I'll choose a smaller group. So users do an initial sign-on when they join the interface for your application. That's the OAuth with the social network. That guarantees that they own that social network handle. The assessment is done to see whether they're a real human or not, or what level of guarantees we could assign to that account. There's tools like Botometer, which we use to assess. Well, it gives us a score to say whether it's a bot or not, and we combine that with a few other metrics to assign that user account into a group. Then at the same time, they're signing a message in MetaMask with their Ethereum account, and that now links. So I'm reluctant to use the word link because the link is not made public, but it's there behind the scenes. So that social network handle now has an Ethereum account linked to it. The link is not made public, so you don't know who's behind that Ethereum account. And the next step is the Ethereum account. There's a message signed, and we produce a Semaphore ID, which is, again, that obfuscates the actual Ethereum account that's behind it, and they're now part of a Semaphore group, and we can use it in the Semaphore application. I'll just mention briefly the normal situation with social networks and other digitalized ID sources. We maintain the infrastructure off-chain, and we just have a Merkle tree root that's routed to the blockchain. We also have some methods where on-chain data is used as the identity source. So we also have a method for on-chain groups. And so let's think of some of the potential applications of Interep. We're going to be hearing from a few of these projects today, like rate limiting nullifier and Unirep. They need that identity layer as an anti-sybil mechanism. And so we can build applications like secret voting, secret private social networks, anti-spam mechanisms like the rate limiting nullifier. We can produce airdrops that are fair in that you can't just have hundreds of sock puppet accounts that collect the airdrop. We can guarantee, provide some level of guarantee that there's a human behind it, and like faucets would operate the same way. We can rate limit to verified accounts. At this point, we're going to do a quick demo of how Interep works. So I'll introduce Sidor and hand over to him.
Hi everyone, I'm Sidor on Twitter and GitHub, and I will show a very simple demo where we use Interep to allow users to vote anonymously using our GitHub Gold group. So here we have our repository, and you can find it in our GitHub organization. Here we have a simple architecture of Interep. Basically, we have 2 web apps. One web app is Interep, and we can join groups there. This one. And the other web app is our client app. This one, where users can vote. In both cases, we need to generate our Semaphore identities in order to join a group. Groups are actually Merkle trees. Interep saves the roots of our Merkle trees on chain every 10 minutes. In our case, every 1 minute. So first of all, we need to generate our Semaphore identity in our Interep web app. Here. As you can see, we have a list of social networks. We need to authorize GitHub. Okay, now we have to generate our Semaphore identity using MetaMask. And Interep calculates our reputation, my reputation on GitHub, and I can join the gold group here. Okay, now Intereps need time to save the Merkle root of our new group on-chain. And after that, we can vote because our client app can connect with our Interep contract on-chain and use the Merkle root and the other parameters to generate an off-chain zero-knowledge proof. And we can verify that proof on-chain, basically. OK. So we need to generate another time our Semaphore identity. It needs time to generate the proof. And we have voted, basically. OK. This is our contract. It's very simple. We have just a function vote with our Interep verify functions here. And that's it.